Right, today in Algebra 2, we're going to finish up section 3.6. We're going to look at the conjugate root theorem. Okay? So the conjugate root theorem tells me, let P be a polynomial function with rational coefficients, let A and B be real numbers. If A plus the square root of B is a root of the polynomial, then the conjugate, A minus the square root of B, is also a root of the polynomial. The second one tells me that if P is a polynomial function, again with real coefficients, A and B are real numbers, then if A plus BI is a root of the polynomial, then its conjugate, A minus BI, is also a root of the polynomial. So we're going to look at writing polynomial functions using the conjugate rule. Okay? So number one, what is a quadratic function P with rational coefficients in standard form such that, first, P of x equals 0 has 2 plus 5i as a root, okay? So if I know it has 2 plus 5i as a root, then I also know that its conjugate, 2 minus 5i, is also a root, okay? So now let's look at how I would write that, okay? So remember that 2 plus 5i, so my equation, or inside my parentheses, it would have said x minus, okay? And then in parentheses, 2 plus 5i, right? Double set of parentheses. And then x minus, another set of parentheses, 2 minus 5i. Because remember that so we'll just come over here and review. So if x equals 2 is a root, then that came from x minus 2. So 2 plus 5i came from x minus that whole thing. So now I'm going to go ahead and just distribute that negative sign here. So then I have x minus 2 minus 5i. Right? I'm going to do the same thing here, and I get x minus 2 plus 5i. Now we could FOIL, okay, or distribute all of this out, combine like terms, or I want to show you a little trick. Notice that I have both x minus 2's here, right? Those are the same. So I could say that this is the same thing as x minus 2 quantity squared minus, these are both 5i's, 5i quantity squared. Okay. So now that I can separate it and put it like this, x minus 2 quantity squared, I can do my shortcuts. Remember the shortcut that I've told you to memorize? So my shortcut says I take the first term and I square it, so x squared. I multiply the two terms together and I double it. So x times negative 2 is negative 2x, doubled, negative 4x. Last term squared, negative 2 squared plus 4. And then I'm going to take and I'm going to double, or sorry, I'm going to square 5i squared. So then I have minus 5 squared is 25, I squared. But then remember, what do we do with I squareds? Those always become negative 1. So here I have x squared minus 4x plus 4 plus 25. Now I just want to combine like terms. So I get my polynomial, P of x is equal to x squared minus 4x plus 29. There's my polynomial. It has 2 plus 5i and 2 minus 5i as roots. Okay, let's look at another one of these. This one says a polynomial function q of degree 4 with rational coefficients has zeros at 3 minus the square root of 7 and 4i. What is the polynomial equation in standard form with these roots? So again, if I know 3 minus the square root of 7, I also know its conjugate. So then I also know 3 plus the square root of 7. If I know 4i, then I also know its conjugate, negative 4i. So again, let's look at where did these come from. So x minus, in my parentheses, 3 minus the square root of 7. X minus, in parentheses, 3 plus the square root of 7. X minus 4i, and x plus 4i. Again, I'm going to distribute my negative sign here, so I get x minus 3 plus the square root of 7. X minus 3 minus the square root of 7. And then here I still just have my x minus 4i, x plus 4i. Again, I notice I have x minus 3 and x minus 3, so I'm going to combine that and make this an x minus 3 quantity squared minus both the square root of 7, so the square root of 7 squared. If I work this part out, again, x squared, multiply x to negative 3, I get negative 3x, double it, I get negative 6x, square my 3, so plus 9, minus the square root of 7 squared is just 7. So this part right now, I have x squared minus 6x plus 2. Okay? So now I'm going to come over and look at this part because I haven't done anything with this yet. X minus 4i, x plus 4i. I recognize that, okay, that has been factored from a difference of squares. If I recognize that, then I can save myself time and I don't have to FOIL it out. I know that this came from x squared x squared plus 16, right? I misspoke when I said a difference of squares. It was a sum of squares because I have this I. If it had just been x plus 4 and x minus 4, that would have been a difference of squares. But since it's 4i and a negative 4i, it was a sum of squares. So this came from x squared plus 16. So I know that plus x squared times x squared plus 16. Now, FOIL these, distribute this out. So x squared times x squared gives me x to the 4th. X squared times 16, so plus 16x squared. Negative 6x times x squared, so negative 6x cubed. And then negative 6x times 16 gets me negative 96x. 2 times x squared plus 2x squared. 2 times 16 plus 32. So now my polynomial, and they told me polynomial q, so q of x, in standard form, x to the 4th, and they told me it was a 4th degree, so I got that right, minus 6x cubed, combine my x squared, so plus 18x squared, minus 96x, plus 32. That is our polynomial. Okay. Right, let's do some more of these. So next page. What is a quadratic equation in standard form with rational coefficients that has a root of 5 plus 4i? So again, if it has 5 plus 4i, I know it also has 5 minus 4i. So this came from x minus, in parentheses, 5 plus 4i, and x minus, parentheses, 5 minus 4i. Distribute your negatives, so you get x minus 5 minus 4i, x minus 5 plus 4i. The x minus 5s are the same, so I can say that's x minus 5 quantity squared minus 4i quantity squared. Use our shortcut, so x minus 5 quantity squared gets me x squared, and then negative 5x doubled minus 10x plus 25 minus square 4i, so I get 16i squared. I squared becomes negative 1, so I have x squared minus 10x plus 25 plus 16. So I'm ready to write the polynomial. They didn't tell me that it was a polynomial p or q or anything like that, so I can pick. I'm just going to say p of x equals x squared minus 10x plus 41. There's our polynomial. Right, let's do another one. So this next one, what is a polynomial function q of degree 4 with rational coefficients such that we have roots? So we have 2 minus the square root of 3, 2 plus the square root of 3, 5i, and negative 5i. So again, x minus, parentheses, 2 minus the square root of 3, x minus, parentheses, 2 plus the square root of 3, x minus 5i, x plus 5i. Distribute, so I get x minus 2 plus the square root of 3, x minus 2 minus the square root of 3. This right here I already recognize as my sum of squares. So this came from x squared plus 25, right? So here I've got x minus 2 quantity squared minus the square root of 3 quantity squared. So here I get x squared minus 4x plus 4 minus the square root of, minus, let me erase that. The square root of 3 squared is 3. So I get x squared minus 4x plus 1. All of that times x squared plus 25. Multiply this out, so I get x to the 4th plus 25x squared minus 4x cubed, minus, switch the wrong sign there, minus 100x plus x squared plus 25. It said polynomial of q, so this is going to be q of x equals x to the 4th degree, so we'll get there, minus 4x cubed plus 26x squared minus 100x plus 25. There is my 4th degree polynomial. So that is day 2 of 3.6, writing the polynomials given the roots using conjugates. All right, our homework today is worksheet 3.6, number 14, numbers 30 through 32, and then 36 and 37.